Welcome to this video. We're going to be talking about linear functions in context. Linear functions are functions where the output values increase or decrease at a constant rate. So the graphs of these functions actually form lines, and hence the name linear functions. But in general, these are just polynomials of degree 1. So here's a function notation for a general polynomial. You notice you have a0 plus a1x. X is the only variable there. It's a degree 1. So we call this a degree 1 polynomial. Now we more commonly write these functions in slope-intercept form, y equals mx plus b, where we know that m is the rate of change and b is the y-intercept. So let x1 and x2 be any two input values for a linear function, and y1, y2 be their respective output values. We can actually calculate the rate of change, that constant rate of change, by using this formula, and we denote it with the letter m. So y2 minus y1 divided by x2 minus x1. In general, you're taking the difference or the change in the output values and dividing it by the change in the input values, and that's giving you a constant rate. Now we define the output value for x equals 0 to be the y-intercept of the function. And really, in the context of many real-world problems, the y-intercept is usually the starting or the initial value. So we need to know this y-intercept to uniquely define a linear function, and we actually denote it with the letter b. So b is the function value at 0 or at x equals 0. So suppose you are given a situation and you want to model that situation with a linear function. There are two things that you must determine, and we just talked about them. Number one, what is the constant rate of change, or m? And number two, what is the initial starting amount, or b? Once you determine these two things, you can go ahead and write the equation. So let's try a practice example. Piper is going to use a computer at an internet cafe. The cafe charges 60 cents for every minute using a computer on top of an initial charge of $6. Make a table of values and then write an equation for C in terms of T, representing the total cost of using a computer for T minutes at the internet cafe. So let's start with number of minutes equal to 0. Well, at 0 minutes you haven't used the computer at all, so you're just having paid the initial charge, so that would only be $6. After you used it for 1 minute, well, they charge you 60 cents every minute, so $6 plus 60 cents gives you $6.60. Again, 2 minutes, add another 60 cents, you get to $7.20, and then add another 60 cents gives you to $7.80. So now we're going to look for what is m and what is b. What is the rate of change and what is the initial amount? Well, it's pretty clearly stated here. First, we see 60 cents for every minute, so we know that m has to be 60. Or excuse me, 0.60 dollars or 60 cents. And then we're told there's an initial charge of $6. That initial charge is our y-intercept, so b equals $6. We can put those two things together and write our equation. Using function notation, c of t equals the initial amount 6 plus 0.60 or 60 cents times t, the number of minutes. Alright, and that's it for this video, so go ahead now and try some practice on your own.